Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Ajay Kumar Garg Engineering College, Ghaziabad. I am before you to present the video lecture for the complex topic series for the subject Data Communication Networks, which code is as the AKTU syllabus, that is BEC 062. So, in this subject, I am just using select the topic Hamming codes here. So, Hamming codes is very essential topic for the which I have chosen just because of it has the when we have to go for the data link layer, which is the second layer from the bottom in the ASI model as well as the TCP/IP model. It used to provide the which is responsible for flow control, error control part. This is it's a main utility of this data link here, which is responsible for this in the networking. It is used to flow and the error control part. So, while we are doing for the error control, we are using the Hamming code. This is the most efficient code for the error detection. First of all, it is need to detect the error, and after that it is need to correct it. So, how it can be possible? It can be easily done with the help of Hamming code here. So, what is this Hamming code? So, we will see it now. The Hamming code, which you can see here, the Hamming codes are an important error detection. Hamming codes are an important error detection as well as correction techniques used in the data communication system to ensure the reliable data transmission. The things that has to be, I have underlined here, that is the error detection. That means some the information which has been transmitted from the sender to the receiver. When the sender will transmit the any message information, it will travel to the with the help of physical layer. It will transport transported between the sender and receiver with some via some media. Maybe it's in a wireless media or wired media. So, but there is a chance that the error should take place. That means either due to noise or something else, the error can be possible. So, in the similar way, in this way, now it is need to the responsibility of this error to just to use anything else in between while transmitting data, so that if any error occurred during the transmission, the receiver will able to identify detect the error and able to correct it. So, how can it be possible? For that point of view, the Hamming codes are using, and while if any error is happened or occurred during the transmission, then the receiver responsibility is to detect it and then correct it. So, this will the meaning of this, which will provide the reliable data transmission here. So, Hamming codes are a type of linear error correcting codes. So, its major characteristics or its advantage, if its major significance is that detect up to 2-bit errors. That means, if we are sending the data of 15 bits, let's say including the parity bits, it can use to detect the 2-bit error will be any there, but correct only 1-bit error. So, this is its significance. So, can be able to detect 2-bit error and correct only 1-bit error. So, the advantage, first of all, it is simple and efficient. Next one, no need for retransmission for single bit error. So, that means single bit error can be easily detected and it is now corrected, so that the receiver will get the exact information. So, there is no need for the retransmission of the original message again if the error happened if on at the single bit level. Now, widely used in memory system, RAM. The applications are just computer memory, data communication system, satellite and wireless system here. So, the Hamming code is the along with this advantages and applications, the Hamming code is based on the adding redundant bits using mathematical parity checks to identify and fix error automatically. So, this will line will explain regarding the what is its we can say that how it can be performed mathematically. How can it will be able to detect the data or correct it? So, for that point of view, the redundant bit concept is used to here, where the parity check some method can be applied here. Redundant bits or parity bits are the additional bits that has to be applied while during the transmission. Some extra bits can be encoded added during the along with the message signal during the transmission. So, how it is will happen? So, for that point of view, just let's say consider an example of a message signal let's say we have taken a message signal that is 10111110 here. Okay, this message we have to transmit with the help of Hamming code, that is 10111110 here, using parity checksum. So we are using that, let's say, two methods, that is either even parity or odd parity. It can be performed with the help of either even or odd parity, but our conversation into just to demonstration for this Hamming code, we are using this even parity method here. So how can it be possible? So what should be the Hamming code for this code? Message signal 10111110. What will be the Hamming code? We will now try to clear it, understand it. So for that point of view, first of all, we have to consider what is the length of this message signal. That means how many number of bits can we going to use here. The first point, we have to clear that what will be the length of this message. That means length means how many number of bits are now going to use here. So as we can see that 1, 2, 3, 4, 5, 6, 7. So there is length of this message signal is now 7. Okay. Now next part is that how can be the redundant bits or the parity bits we have to add it here along with this message signal. So how as per this length of message m is equals to 7, how many extra bits we have to add it here. So the first point now we have to include here, that is the number of extra parity bits to be added, which is given by 2 raised to power of p is greater than or is equals to m plus p plus 1. Okay, this will be the formula. With the help of this formula, we have to able to identify how many number of extra bits to be parity bit should be added here, which is given by this formula. 2 raised to power p is greater than or equals to m plus p plus 1 here. So in this case, if we see for this one, p value, where this m is the length of the message signal and p is the number of extra parity bits, how should parity bit should be added here. So it's given, if we see for the m is equals to 7, 2 raised to power p is equals to p plus 8, because m is equals to 7 plus 1 will become 8. So for the possibilities, either now you have to select the values of p is equals to 0, 1, 2, 3, 4, 5, like, p is equals to not 0, p is equals to maybe 1, 2, 3, 4. If we will select, let's say p is equals to 1, the value of this p is equals to 1 what? 2 raised to power p, if we select p is equals to 1, let's say, so 2 is greater than equals to 9. This is not matching. So we cannot consider p is equal. Similarly, p is equals to 2, then p is equals to 3, let's say. So in case of p is equals to 3, if we select, so 2 raised to power 3 is 8, or it is greater than equals to p3 11. It is not acceptable. So now we choose the value p is equals to 4. So in that case, 2 raised to power p 16, 2 raised to power 4 is equals to 16 plus 8 plus 4 12. Now this will satisfy. So we can choose the value here, that is the p is equals to 4 here. So in this way, so the total bits in the Hamming code which has to be sent, that is equals to m plus p is equals to m plus p is equals to 7 plus 4, 11 bits. Now the Hamming code which has to be sent here, it is of now length of total number of bits in the code which has to be sent along with this message, including the parity bit, is equals to 11 here. So the next point come into the picture, that is the location of parity bits. the next point, where that means what? All length is 1 to 11. Now we can write it also like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now in this we have to keep the values of this message of 11th bit message, which included the parity as well as this message signal. So how can it will be decided? So the location of parity bits can be depended upon the 2 raised to power of nth location. 2 raised to power of nth location will decide the position of the parity bits location in the entire message, which is of 11 bit length, where this n value, because p is equals to 4, so it will be start from 0 to p minus 1. So that is 0, 1, 2, 3 here. Okay. Now what is this? 2 raised to power 0 position is this. It is 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, 6, 7, 5, 6, 7, 2 raised to power of 8 here. So for the parity bits, if we see, so the parity bits at the position 2 raised to power 0, that means 1. So P1, 2 raised to power 1, 2 raised to power 1, that is 2, means second position, that is P2 bits. Next one, 2 raised to power 2, means 2 raised to power 2, 4, this one. So it is having the P4 bit, parity bit. Then now 2 raised to power 3, that is 8, means here P raised to power of 8 here. Now this is the position of parity bits in this message, and the rest of the position we have to put the value of this message 10 11 11 0. So start from the left side 1 0 1 1 11 and 0. So this will become now the complete message which has to be transmitted through the channel from the transmitter. So this will be the now position. It is now we have noted here 101 P8 111 P4 0 P2 P1. Now the next task after the location of this parity bits, the next task is to where these, what is the value of this P1, P2, P4 and P8. Now our next task is to evaluate this part. So the next point, we have to calculate the parity values. So what is its value? Now we have to select it. So for that point of view, so the total bits we have to use here 4 parity bits P8, P4, P2, P1. Okay. Now we can write it like this: P8, P4, P2, P1. Next, in this column, we have to write the total number of bits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and now let's say this is now 11. Now our next task, that is to we have to write their binary number as corresponding to this location. 1, it is 0, 0, 0, 1, 2, 0, 0, 1, 0, 3, 0, 0, 1, 1, 2 and 3, then 0, 1, 0, 0, 0, 1, 0, 1, 4, 1, 5, then 0, 1, 1, 0, then 7, 0, 1, 1, we can write it like this. Then now 8, 1, 0, 0, 0, 9, 1, 0, 0, 1, 1, 0, 1, 0. Okay. Then next 11, 1, 0, 1, 1, 0 here. So after writing this, now what we have to do, that is the we have to trace the location. The value of what is P1. So let's say that is P1 we have written here P2, P3, now P4. So for that point of view, what we should do, we have to, along with this location of P1, we have to, in this column of P1, we have to calculate the position value of 1. At which position the 1 is coming here. So P1, in case P1, that is at 1, 3, 5, 7, 9, 11. 1, 3, 5, 7, 9 and 11. That we have noted here. Now for the 2 at second position, third position, 6, 7, then 6, 7, 10, 11. We have written here. Then just a little bit mistake I did. That is it is a P4 or P8. So P4 position we will see it is position 4, 5, 6, 7 position. Similarly, it is at 8th, 9th, 10th and 11th position here. So this is the position now we have marked. After that marking this position, now we have to check from data what the values can be mentioned there. So at P1 position, third position, P1 is parity bits. In the P1 case, we will see at this one is as per the message 101. Here this 101 P8, 111 P40. First position it is P1, third position 0, fifth one, seventh one, ninth one, 11th one. Okay, in this message we have to keep the value here. That is 1, 1, 1, 1, 1 here. In the same while, we can now write from this 3, 6, 10, 11, 3, 6, 7, 10, 11, 3, 6, 3 pe at the position 3, 0, then 1, then 7 is 1, then at 10th position 0 or 1 here. Now, we can now also write here P2 is at second position is parity bits. Here it is 0, 1, 1. At the 10th position, it is what? 0, 0 and here it is now 1 here. In the same meanwhile, 4, 5, 6 position, we can similarly check 5 is 6, 7 at 7 position is 1, 1, 1, 1. Or 8, 9, 10, 11, that is P8 is a parity bit, that is 9th position is 1, 0, 1. So we can now write it here, what? 1, 0, 1. So after marking the location, our now next task is to mention this, the value of this what. So here we have to now use the parity check method. What we are going to use here for the making this, we are using here the even parity method. So along this even parity method, we have to count the value of this parity weights for the P1. What will be the value of P1? So for that point of view, we have to count the number of ones here. So here 1, 2, 3, 4, 5. Okay. Sorry, that is something 1, 3. It is 0. Sorry. At third position, it is now 0 here. Sorry. As you can see in this third position is 0, which is I have written wrong. So you have to calculate the total number of ones in this P1 parity positions 1, 2, 3, 4. So the number of ones will be even. So we have to maintain the even parity. Even parity is saying that the total number of ones should be 1, or in odd parity the total number of ones should be odd. So in this case the total number of ones will be even. So the P1 will be 0 here. If we add here 1, then it will become odd. So which is wrong as per the given method. So it is 0. Similarly for P2, if we see, then it will become what? 2, 3, 1, 2, 3. 3 number of ones will be 3. That is odd. We have to make it even. So we have to keep it here 1. So P2 value will be 1. Similarly, P4 total number of ones will be 3, it will become 1, or total P8 2, so it will become what? 0, because already even total number is even, so 8 should be 0 here. So the parity bits will be 0, 1, 1, 0 here. So now we have to put these values into this message. So the original message which has to be transmitted that is will become which will become 1 0 1 0 1 0, then 1 1 1 1 0 1 0. So this message has to be transmitted, where this position, this position, this position, 4, 5, 6, 7 and 8, these are the parity position here, 1 0 1 1 1 1 0 here. Now this message now should be transmitted. Let's say during the transmission, the received message code is, let's say, 1 0 1 0, then 1 0 1 1 0 1 0. Okay, this means 4, 5, 6 number position we have changed here. This one, this position is now changed here in the received code. What is will become 1 0 1 0 1 0 1 1 0 1. It is now received here. Now the receivers will now check it's a possibility that what is the actual information has to be transmitted. From the actual information, it should be now parity bit should be removed. So for that point of view, what will become now, the reverse message will be checked here. So now here, the first of all part, we should identify, the receiver will know it is this message having the 4 total length 11, where the 4 bits are for the parity, where the positions are P1, P2, P4, 5, 6, 7, or this one is now 8th position. These are the parity bits in the transmitted message. Now after that, this transmitted message, what should be procedure should follow, that is P1, the P1, P2, P4 and P8. Let's the parity check positions as per this one 1 3 5 7 we should write here first of all. So that is 1 3 5 7 9 11, 1 3 5 7 9 11, 2 3 6 7 10 11, 2 3 6 2 3 6 7 10 11, at 4 5 6 7 8 9 10 11 we can now write here. Along with this, we have to write this positions at that particular position, what is the value of bit. So we have to now write it here, the actual information. Now we should write here, that is at the including the parity bit. So here P1 will be 0 0, rest of the bits are 1 1 1 1 here. From the original message we can see that 0 1 1 1 0 and P1 will be 0, we can now use here. In the case of 2 3 6 7, so it is 1 0 0 what from this message, this value we should write here, because the bits has been changed 1 to 0. Then 6th, 7th position is having 1 and 10th position is having 0 or 1. This bits now we can write from this code. We are writing with this received code. Position we are getting from this, which we are using, that is only for the reference. Now 4, 5, 6 position, it is what the values it is having? 1, 1, 1, 1, 0, 1 here. From that you can see here 4, 5, 6, 7, 1, 1, 0, 1 here. 8, 9, 10, 11, 8, 9, 10, 11, 0, 1, 0, 1, 0, 1, 0, 1. We have now written here like this. After that, now our task is to calculate the even as per the even parity as used here. So check the parity number of values, is it odd or even. So in the P1 case 1, 2, 3, 4 it is even. In this case 1, 2, 3 odd. Fair. Then in this P4 it is odd, it is even. So after mentioning that, now the next task we have to check the conflict. Conflict is what? According to this one. In this way we can check, we are using the even parity. So the number of ones is even, parities we are using even, so there is no conflict. Odd, but parity is even, so it is an yes. In this odd it is yes, even that is no. Now no will corresponds to 0, 1 should corresponding to 1 we should consider here, and if any ones error occurred in this conflict, which will show that the error is detected. In this, in the conflict, any ones shows the error is now detected. So the error is detected, it will showing that 0, 1, 1, 0, so that these two positions, the 1 will be there. Now it is clear that there will be a error here. Now what should be, at the which position it is now going on. So for that point of view, what should we do? Simply from bottom to top, you write the numbers. From bottom to write the number here, that is the 0 is here 0, 1, 1, 0, 0, 1, 1, 0, that is binary. At its position, at this will show at the which particular position the error is now detected. So 0, 1, 1, 0, 1, 4, 2, it means 6th. It will show that as the decimal value of 0, 1, 1, 0 is 6. That means 6th position is having error. Now, so how error can be detected? So how it should be corrected? So for that point of view, complement for the error correction, complement the 6th position complement the 6th position. That means 1 should be 0 or 0 should be 1 here. So now the message is what received is, that is 1 0 1 0 1 1 0 1 0 1 1 0 1 0 1. It is 6th position where the error detected. So its complement will be 1 here. So 0 will become 1. That means 1 1 0 1 0. 1 1 0 1 0. So this message now received here, at the receiver will detect the error and corrected this position, 6th position here. Now parity bits, this one P1 is parity location already known, P4 and now P8 here. So the original message at the receiver will remove these parity bits. So it will detect correct the message 101, then the 111 0. So this message is now received by the message. As we can check the message 1011110, 1011110 is now received by the receiver. Okay, so in this way, the Hamming code will perform the error detection and the correction. So thank you from my side. Thank you and Jai Hind.